All right, awesome, cool. Welcome everybody. Hi, my name is Ariel Perez. I am the field CTO at Tinybird. Today we're gonna have an awesome webinar. We're gonna be talking about outgrowing Postgres, and taking us through that journey and outgrowing Postgres is gonna be the team from Blacksmith. So we're gonna get lessons from a YC startup. Here with me I have three members of the Blacksmith team. We've got JP, Madhu, and Ayush. Gents, can I ask you to please introduce yourselves? What do you do at Blacksmith? And then, actually, most importantly, diving right in, what is Blacksmith?
I can kind of kick that off. Hi everyone, nice to meet you. I'm JP. I'm CEO at Blacksmith, and on a high level at Blacksmith, we help companies run their GitHub actions up to twice as fast at half the cost, and we're a one-line code change to try out. That's what we do. And a little bit about me. I studied computer science at the University of Waterloo in Canada. That's where we all met. And then I did grad school for a couple of years, and then I worked at a wholesale B2B startup called Fair. And earlier this year in Jan, we all left to start Blacksmith. So that's a little bit about me. Ayush.
Hi everyone. My name is Ayush. I'm one of the co-founders and the co-CTO of Blacksmith. A little bit about me is I also went to Waterloo, like JP mentioned. I was roommates with Maru for a while at various points in college. We then were also co-workers at Cockroach Labs, which is where we spent most of our career so far. And we encountered this sort of endemic problem with just like CI slowness that kind of just like compounded over our time at Cockroach. And earlier this year decided to do something about it, and here we are.
Awesome.
Sweet. Hi, everyone. My name is Aditya. I also go by Maru because there's two Adityas in this call. I'm also co-founder and co-CTO. It's always hard to go last because Ayush takes away most of the stuff which we've shared over the past 7 years. We've done pretty much the same things. I was at Waterloo as well, then at Cockroach Labs for almost 4 years. And then, we decided to start Blacksmith, and we've been building that over the past 9 months at this point. Both in terms of offering a better experience for speed and cost for running your GitHub actions, but also the topic of this call, which is about the richer, deeper analytics which we provide. So I think that's a good transition to hand this back to you.
Awesome. Thank you very much for that. It's funny how we overlap and cross in so many circles. So first of all, we used Cockroach extensively in a major project I was working on a few years ago over in the UK, trying to launch Chase in the UK. So I know if you guys were in Cockroach at the time, we probably gave you a bunch of headaches as a major customer, really pushing Cockroach to its limits. And then later on at my last company at Split, I definitely wish that something like this would have been around because I spent quite a bit of time on GitHub and GitHub Actions. And also, having my infra team saying, hey, you're spending a ton of money here, wanting to automate, but also trying to balance that with cost. So pretty awesome that we've got something like Blacksmith around now. So for the audience, again, we're going to be talking about outgrowing Postgres as you evolve and go through your analytics journey. And these folks are going to take us through that. I want this to be interactive as much as possible. I have a bunch of questions, and we're going to be diving through this. But for the folks on the call, please feel free to ask questions, raise your hand, throw questions in here. The team behind the scenes is going to be helping us field those questions and bring them up so that if I miss something and you want to cover something, please feel free to join in and start throwing questions for the team. So on that note, we're going to dive right into talking about analytics and what does analytics look like inside of Blacksmith for you folks, right? So what were you building and trying to build in Postgres, which for many companies, right, Postgres is such an amazing database. You start building on it and you start building more and more and more. And eventually every use case, we're like, well, let's just throw it on Postgres until it doesn't fit anymore. So what does analytics look like in your product? And at what point did it start stressing Postgres?
You're muted.
I think Ayush is on mute.
I can take a quick stab at that. So yeah, like you said, we started on Postgres. Postgres is kind of our source of truth database. At the moment, everything goes through our like centralized control plane, which is built on top of Laravel, which is this like popular PHP framework. And we started running into a few issues as we started, getting customers, and the customers started clocking in usage on the platform. One of them is that the payloads that we get from GitHub regarding information about or metadata about a given GitHub action job, they're fairly verbose and they add up fairly quickly. So just to give you a sense of our scale, already with just being in business for 7-8 months now, our histories table that tracks all job executions on Blacksmith has grown to over 100 gigs, and that's uncompressed in Postgres. So naturally, we wanted to build analytics in our app to help users kind of understand trends within their GitHub action jobs and how they've been regressing or not over time. And there's really no convenient way to do this right on top of Postgres when you're dealing with a table that has 100 gigs of data. So yeah, I can kind of dive into what we considered as we like went through this journey. But even 4 months ago, this table was already dozens of gigabytes, and it was already untenable to run the equivalent of what would be full table scans on that much data every time one of our customers refreshes their Chrome.
So I think that one's interesting. Even saying early on, even before you got to the 100 gig place, what kind of queries were you trying to run? So obviously you tried running this on Postgres first. You would assume it would work, right? Postgres is so great, it's so fast, it can scale very quickly, a lot of connections. But what was it about these particular queries that started giving you trouble on Postgres?
So a common example of what we run is one is just like vanilla aggregations to figure out like your sort of quantile for a given workflow or job. Like, what is the P95 runtime for this GitHub action workflow? Or, what is the median runtime? Those sorts of aggregations require basically like a full like shuffle over your all instances of that workflow, because you got to rank them in order of their runtime, hold all of that in memory, and then pick whatever is the P95th time. So those ones gave us the hardest time. We initially considered effectively writing a materialized view that we would periodically refresh. I think other companies look into doing things like rolling them up on a daily basis and then running the final aggregation query over the rollups. And we looked into those options. None of them seemed quite as appealing, because we did want our UI to relatively quickly reflect one of our users' jobs, right? One of the things we heard recently from one of our customers is that they liked how quickly our UI reflected the changes they were making to their workflows while they were doing a POC. So that's a practical example where you do want some recency in your UI, and solutions that roll up a materialized view or do the sort of thing once an hour or something, they don't quite have that level of tactility.
I think just adding to that last point which Ayush brought up, even looking forward, currently we have these workflow level analytics which allow you to track how your performance has been over a few days. But our goal really is to go a lot deeper, such that some of these analytics can be used to assess whether a change which you make today and you merge to main is going to significantly drop down your runtime for a particular CI job. People today rely on clicking through GitHub's slightly clunky UI to figure out whether a change in a workflow which they did or a code change speeds up their CI. If you want this fast feedback loop, then you need to rely on something which refreshes much more frequently than like a materialized view would be capable of.
Got it. Awesome. I mean, that really speaks to the point of the importance of freshness and the importance of as close to real time as possible, right? As you're saying, an hour ago is too late. Even maybe 10 minutes ago, probably not good enough. At some point, you need to draw the line of like how fast you need it to be. So you explored materialized views and rollups in Postgres. What are the other things you started exploring? And actually, before that, you were seeing a lot of data coming in. At what point did you realize like, hey, this isn't going to work? Were there some pain points you started feeling and seeing? Was something going off in your monitoring? Were users complaining about like loading time? What was it that told you like, hey, this isn't working? We've got to do something about this.
I have a funny anecdote about this, which was almost like a half outage in our service, and this was like an interesting consequence of Laravel just being relatively connection hungry as a framework. This is because Laravel doesn't support transaction pooling. It only supports like session-based connection pooling, which means that in case of like a web request that makes a bunch of expensive queries, if one of these requests is doing a full table scan that takes 30 seconds, it's effectively hoarding up that connection slot in our connection pooler for those 30 seconds. And if you sort of time it just right or just wrong, that can starve out other requests from being able to get a connection slot. And like Postgres, for as great as it is, its connection handling story is still not like as lightweight as you would like. I think they're making improvements in recent versions of Postgres, but we effectively had a blip that lasted a few minutes because one of these queries, one of these like dashboard powering queries, were just like hoarding up our connection slots. So that was kind of one big like kind of spur for us to figure out an alternative to this. And the other one was just like as Maru mentioned, we wanted to go deeper in this like analytics direction. We initially started with like a per repository view of your CI pipelines, but we want to keep going deeper. And we just realized the amount of work we would have to do, like with every incremental layer that we wanted to add, just setting all of these like roll-ups up for each of the metric that we want to surface. We just wanted something that allowed us to like move faster.
I think internally also, like amongst the three of us, alarm bells started ringing pretty early on that like any internal tooling that we build on top of Postgres has the ability to like directly impact the core of the business, which is adopting GitHub Action jobs and running them. And that started giving us like pause very early on. Like we knew we were one bad billing job query or one bad like internal tooling refresh away from a full-blown outage. And the minute you start like getting serious customers and usage, if you block people's CI, the angry message will end up in Slack or your email within minutes. So I think JP has some thoughts about some of the internal tooling, which we also started building out on Postgres and then moved to Tinybird for.
Yeah, I can talk a little bit about that. Oftentimes we get requests from customers, asking us to like help debug their workflows, understand regressions, and potentially even suggest ways that they can make it faster. And simply what that really involves is us having a line chart, seeing if their test duration grew over time. And those were some of like, we use an internal tools, framework like Retool, and we had that set up on Retool. But we noticed that the Postgres queries, they started taking quite some time, and we started getting concerned. Like Maru said, is this going to lead to like a full-blown crash? Today, what we do using Tinybird is we're huge fans, and I'm personally use it a lot, of your pipes feature. So we write the same SQL query, create a pipe for it, create an API, and boom, we have it working in no time. And the best part about this has actually informed us about what we should be building for our analytics offering, because these are the dashboards that we're looking at, and which means that this is something that our customers would eventually use.
Awesome. I mean, I love hearing stories about the things that Tinybird makes easy, and the different features and capabilities of Tinybird that you love using. I'm going to ask you to hold on to that, because I think there's still some pieces that folks in the audience can really learn from, right? And I want to go a little longer into your pain, right? And the things that you found out, the things you learned, and how you came over to the other side. I think other pieces of context, right? You were talking about the fact that you were getting to about 100 gigabytes of data very fast. How big is your Postgres cluster? Vertically, how big it is, horizontally, how big it is? Can we talk about the scale and size of Postgres, either until the point you decided to do Tinybird, or when you were trying some ideas? Here's the quote unquote easy answer. For the folks who have enough money, why didn't you just scale it up and out?
I think the short answer to that is our Postgres instance already is fairly vertically scaled. So it's if you're familiar with the Amazon or the AWS instance sizes, it's a 4x large already, and that's 16 vCPUs. I want to say 64 gigs of RAM. We also have a read replica on it, so some of these more expensive queries now run on the read replica. However, I think a lot of this, and maybe this is what you're alluding to, a lot of this is sort of a limitation of Postgres's row-based architecture, right? Even if you throw more resources at the Postgres instance, it's actually not going to make your analytics queries that much faster. You might be able to do more of them in parallel, and it might mitigate some of these connection starvation issues that we were talking about. But it's sort of a band-aid, a temporary band-aid at that. And yeah, we were we have to invest in some solution long term. We might as well try to do it now when the cost of evaluating something is not that high.
Got it. So it seems you decided to rip the Band-Aid off very early before even trying several different things. I mean, one of the things that came to mind, did you even get to the point of, what, I think to JP's point, and actually Madhu saying, we cannot have this bring down one of our key use cases. We cannot let these, the user tools and the internal tools bring down the entire platform. Did you ever consider segregating the workloads and say, here are the Postgres instances just for the internal stuff, here are the ones for the critical work, use cases? Those are some of the paths and journeys I've seen folks take in the past. Did you go that route? And if not, why not?
So I want to say the read replica was sort of a half step in that direction. That level of segregation at least makes it such that our core events, which are webhooks from GitHub that tell us about incoming jobs for our customers, those at least aren't really contending with some of the queries that the dashboard might be issuing. However, they still sort of contend within one another, right? If you have multiple concurrent users accessing your dashboard, our dashboard is already quite heavy in terms of the amount of load it puts on our database. And it was a necessary band-aid at that time, but even so, it wasn't enough for the way we're growing and the way our usage is growing.
Yeah, I think just echoing that, I think we were pretty aware of the use case of time series data only growing from here on out. And so I think the three of us just started looking for products that solved for that specific use case rather than trying to extend Postgres. We love Postgres. Even having worked at Cockroach, we were most familiar with Postgres. But I think we took a very what is our problem? What are we trying to solve? And let's not try to shoehorn the solution into Postgres if there are better solutions out there like ClickHouse and Tinybird and stuff like that. So I think that was the sort of whiteboarding which we did. So I guess in retrospect, thankfully, we didn't spend many weeks trying to get the read replica up, and we made the right choice, at least for now, with what we've gone with. So
awesome. So I mean, I guess you got very lucky that you decided as a team, you know what, this just isn't the right tool. We can continue to try to shoehorning things in here and add more resources, but it's just not going to work. And you decided it's not going to work. So you started looking at solutions for time series and how to handle that time series data. So at that point, was Tinybird the only thing you guys came across, or what else did you consider before getting to, we think Tinybird is the thing?
So we considered, I want to say we seriously looked at timescale, which is just like Postgres extension specifically for time series data. And that was a compelling solution because, it would have allowed us to keep everything in our Postgres instance. However, it had some compatibility issues with Laravel's like ORM. And that was one issue. We would have to sort of fight the framework a bit to have like migrations work in our unit test, for example. And another big limitation was that like timescale is still just a time series database extension to Postgres. I would classify our use case as sort of a hybrid between time series data plus just general like analytics processing data. And it just felt like ClickHouse was the place to look at. So initially, we actually started off assuming that we're just gonna like self-host ClickHouse because we have a bunch of experience like self-hosting databases from a different time, and we were like, why not look into just like self-hosting ClickHouse ourselves? And we went on that journey. We tried things out. We realized that we would still need to work on effectively like an ingestion solution to get our data from our Postgres instance into this ClickHouse instance. We looked at a bunch of hosted offerings for that. And soon it kind of became clear that it wouldn't be as simple as, just like self-hosting or even like going with the cloud-hosted ClickHouse version. It's all this like plumbing that we would have to do in the middle that even got our data from Postgres to the ClickHouse instance. And right around then is when we also stumbled onto Tinybird. So that was kind of our like initial journey.
Very cool. And sorry, Maru, I cut you off. Go ahead, Maru.
No, I was just going to say another angle to keep in mind at that point is, even still, our main goal is to ship quality features fast. So like a lot of these decisions were like 30-minute or 1-hour decisions, which were like, hey, this is going to slow us down too much. Self-hosting is what we prefer, but we don't have the capacity to like spend 3-4 days building out this ingestion pipeline. We'd rather focus on XYZ. So I think Tinybird like came at the right time where it allowed us to iterate a lot quicker. And that was also one of the big motivations of like choosing it. So
awesome. So I think what I was going to say was, I'm glad you came to the realization very quickly that running your own ClickHouse isn't an easy endeavor. And I've got the team behind the scenes. If you folks can share actually out to the crowd to as they're considering this thing, right? Absolutely. If you've got the team, and I think to Maru's point, if you've got the team and the time and the ability to dedicate true resources and people to running your own ClickHouse, by all means, this is a spectacular database, unbelievably powerful. That's why we've chosen it. At the same time, we know how hard it is. We know how difficult and complex it is to run it on your own. So what I was going to ask the folks in the background is if the team can share links that we have on that topic on running your own ClickHouse, on what you have to think about when you want to run it versus get a hosted option, and usually why a hosted option is a better solution for you, especially in this particular case when you guys are talking about. It's interesting and awesome that you bring up the fact that you had to think about how to do the ingestion into Tinybird. If you evaluated or looked at least other cloud hosted options for ClickHouse, what was it about those options that didn't give you confidence that you would be able to get that data from Postgres into ClickHouse? And conversely, what was it about Tinybird that gave you that confidence that, oh, we can probably do it with Tinybird much more easily?
I want to say that it wasn't anything that seemed particularly deficient with the existing kind of options to get data from Postgres to ClickHouse. It was more that they all required setting up some additional piece of infra, particularly something like Kafka, right? Like I think the traditional way that a lot of these products or systems recommend that you set up this pipeline is you hook up your Postgres instance to some kind of CDC change data capture stream that on the other end is picked up by like your ClickHouse instance. And that would have been a good solution if we had no other option. I'd say like what really won us over with Tinybird was two things. One, your self-serve flow. We're pretty big believers in just having a very powerful self-serve flow, unless you like absolutely cannot for the type of product that you're trying to sell. And second was the HTTP ingest API. Obviously, it doesn't work for like very large scales. Like you don't want to be kind of microbatching and ingesting via HTTP once you're past a certain scale. But for our scale at that time, it was perfect, right? It allowed us to show up to your UI, create an account, sign in, set up the HTTP ingestion, and just like try it out. So in the span of 2 hours, I basically had like a prototype of the dashboards that we wanted to power on our UI and a way to get all of that data into Tinybird. And that in particular was like very confidence inducing. And it just became clear, the amount of infra that we would not have to deal with if we just like went with the solution.
Awesome. That's huge. And I think that starts talking to some of the things that JP got into. So, it's amazing to hear that, within 2 hours, you kind of built one of your use cases and it's like, hey, I can see it working. What other things stood out to you from your experience with Tinybird? Like, what were the things that really helped nail down, like, I'm loving this more and more?
I want to say the frequency with which we keep discovering like new use cases is pretty surprising. Just as an example, I think I may have like mentioned this before. We do a lot of like internal benchmarking on our like platform. So we have a fleet of like hardware that we maintain. And if you're maintaining hundreds of machines, some of them are going to fail at various points, and the failure modes are fairly they're fairly heterogeneous in the sense that you might have like a bad disk on one of them, and those disk failures might show up in various ways, or you might just have like some sort of like operating system level like issue on one of them, or you might just like have just like overall degradation over time as the fleet runs customer jobs. So we effectively have to track a lot of like telemetry data from all of our host machines regarding just the health of the hardware itself. And that's not a problem that we foresaw, right? Like 6 months ago, this was not a problem that we even foresaw. But today it's very much a problem that we have to keep tabs on. And Tinybird's kind of become our data lake, if you will, or our time series database for this use case as well, where all of the metrics that we collect from our host machines are just like dumped into Tinybird, and they power a retool dashboard on the other end. And we had to not spend a ton of time setting that up because the hard part is kind of abstracted away. So I think that part of it has been like very surprising. We sort of discover new use cases fairly regularly.
Awesome. JP, were there any other ones for the... Oh, sorry, go ahead, Madhu.
No, I was going to say, I think that's another place where like the HTTP ingestion endpoint just like shone through for us, because all we had to then do was like write a GitHub action, which we're like very familiar with, and do like a FIO disk benchmark and just like dump data into Tinybird. You go into Tinybird, you can see the raw data, you can chart the raw data. So like we're not at the scale where we want to build out like a advanced internal tool to track like micro benchmarks and benchmarks for these like workflows. We just want some place where you can see key values and then just chart, and like Tinybird became that place for us. So it's effectively, we've grown our fleet to so many machines at this point that it's hard to manually keep track of this. So that is how we monitor whether we need to take a machine out of the fleet and replace it with a newer one. So yeah, I do foresee like many more use cases such as this where we just want metrics and charting. And I think it's just going to be a no-brainer to sort of just keep hooking it up to Tinybird until, you know, we're mature enough to have like an internal infrastructure testing kind of team. So
cool. Awesome. You know, I love seeing, you know, this idea that as soon as people start using Tinybird, you start finding more reasons to continue using Tinybird, and every new use case, like, oh, you know, let's just feed it in Tinybird. You know, other places might think, well, you know, I'll send that to an observability location. I'll send it to Splunk, or I'll send it to Datadog or something else. It's awesome that your first thought was like, no, we can just send it into Tinybird and use it there. So it's really cool that, you know, you get this very wide, diverse mix of particular use cases beyond what you first tried to use it for. I just wanted to get to, you know, the question of, so you started using Tinybird, you decided, hey, this is super fast, and you know, we're coming up with all these use cases. What does your Postgres database look like now? Like after you decided to do this, how's the health of it changed? How have the usage patterns changed? And on the other side, what does your dashboard look like in terms of whether it's performance, whether it's customer impact, whether it's new things that weren't possible before? Like, what does the world look like now after you've migrated to Tinybird?
I want to say the biggest changes, like this whole connection starvation issue that we were struggling with a few months ago, is now like no longer an issue. It's basically like an afterthought at the moment. And we could actually downsize our Postgres instance if we wanted to at this point. We just haven't bothered to do so. But I want to say it's more about the fact that we know that our like business critical operations now have like a very fundamental level of like decoupling from our dashboard analytics. And secondly, the fact that changes to our source of truth show up within the dashboard in a matter of like, I think in practice it ends up being like less than 30 seconds. They've been super helpful for POCs, because one of the big differentiators we have with against like just running your actions on GitHub is the richer analytics that we provide. If customers can do a quick like, you know, trial run, use our like migration wizard to migrate some actions over to Blacksmith, and just see the metrics show up in the UI, like that quick time to value is like, it's proven really useful, because then it makes it more and more of a no-brainer for people to, you know, just do like a prolonged POC and then eventually convert to like paying customers.
And I just want to add that this is a flow that we see over and over again. Like we use Posthog to like look at what our customers are doing in our dashboard, and they'll sign up, use our migration wizard, do a POC, and 5 minutes later come back and look at the P50 and the P99 of all the runs that they just tested us on. So having that data in our dashboard in under like 5 minutes ideally is super critical.
I just wanted to add, like, going back to your question about like what our dashboard looks like today. Our dashboard is currently so GitHub sort of breaks these down into like workflows, jobs, and even within the jobs, then there's like a notion of steps. Our dashboard today is a workflow level analytics offering. The thing that Tinybird lets us like unlock is that we can now go to 2-3 levels deeper, which is like job level analytics and even like step level analytics and traces and, you know, all sorts of metrics that were previously we would have to maybe rethink our database solution as we moved down each rung of the ladder. Now the problem boils down to, can we churn out Figma mocks fast enough? Can we wire up the backend fast enough? Can we write code which has been written hundreds of times fast enough? So I think the fundamental like infrastructure limitations are not even on the horizon at the moment, which means that we can ship this in 3 weeks if we put our minds to it, or even quicker. So it's just a matter of prioritization then, rather than like there's this big mountain of data to move from X to Y before I can even think about like designing a solution here.
That's amazing to think about. That is like, can we get our act together fast enough to get this out? Because that's the limitation, not the ability to code something new and ship it. That's pretty awesome. Yeah. It'd be amazing to see that step level and job level and run level analytics, which is pretty cool. Like you couldn't imagine this before. Mm-hmm. It's something we hear from a lot of customers, that things that were previously unimaginable now suddenly are on the table, and oh my God, we have so much work to do because there's all these things that we can chase.
And go ahead. I want to point out that with what Maru just said is like there's basically like an explosion of like data volume with like each level deeper that you go, right? Because a lot of workflows will contain dozens of jobs. A lot of jobs will contain sometimes dozens or hundreds of steps. The moment you start talking about like going down to that level of granularity, it's just like very hard to do it on anything that's like not like a columnar data store. So yeah, like we would not be able to even consider building some of these features out without, as Maru said, like moving like a mountain of data from one place to another before even starting feature work.
Yeah, because each level is at least an order of magnitude bigger than the previous level, and you were already having issues with the base level. That's awesome because going 2 levels down, you're easily 1,000x bigger than before. Yeah. I'm looking forward to the day you guys put that into TinyBird and see how it works. Speaking about moving mountains of data, and I think this is the last question I'll dive into the Postgres journey, and then I think I want to spend some time on like the things you're doing in TinyBird now, more on TinyBird and how you use it. And this is me being a little facetious, but so it's got to be some trouble, right, to constantly have to put the data in both Postgres and TinyBird, right? Like this isn't easy. So how do you get your data into TinyBird on a regular basis without duplicating everything, without copying everything? How does that work out for you? And operationally, how hard or how simple is that?
So at the moment, it's been fairly simple, actually. Operationally, it's been 0 headaches. What we've done is every time an event comes in that we want to also pump or pipe into TinyBird, we effectively spin up a background job in Laravel that like flushes at like various intervals. So every 1 second we'll just like flush whatever data is like come in the last second. We'll pipe that to TinyBird, and that's been like great. One of the things that's been kind of useful is that TinyBird sends us emails when the schema that it expects does not match the schema that was initially set up for this data source. So it like quarantines the rows, and I can kind of go look at it in the morning and see, like maybe 12 rows were quarantined that have a column set to null that was not supposed to be nullable. I can change the schema right there in TinyBird. I can, change a column's expectation from a string to like a nullable string. And like operationally, it's been like really easy because we know we're not really dropping any data. And we know that even if temporarily something is being dropped, it's like very easy to just like rectify. So it's been super nice. Like I'm kind of surprised at how well the HTTP ingestion has scaled. I do suspect as we grow and scale, we'll have to set up like a proper ingestion pipeline using something like a Kafka sync. But we're hoping to put that off for as long as we can.
Awesome. That's great to hear. And, it's interesting you use Laravel to do it in the background. And I think, the interesting thing, you'd probably be surprised how much volume that events API can take. It's one of the things we thought about very early on, even before we had Kafka, making sure that you don't ever have to worry about writing your data, regardless of the volume you have. So it can go through to a really, really high throughput in the thousands of requests per second. Which is also interesting. And you talked about earlier about your concern of how are we going to write to ClickHouse, and we're going to need our own ingestion layer and all this stuff. And that's one of the key areas that TinyBird has spent quite a bit of time investing in and truly fine tuning because for those that know ClickHouse and ClickHouse internals, ClickHouse doesn't like it when you write a lot of frequent, a lot of small writes. It likes batches. So we have this, amazing infrastructure layer in between that allows you to write as fast as you want, and we'll get it into ClickHouse as fast as we possibly can without knocking it over. So, I think it'd be great to see how far you grow before the Events API starts giving you trouble. I do believe it'll be a while. And then, we'll talk to you about like how we get you on Kafka and, how easy it is to set that up and click it in as one of our connectors. So I think that covers most of the bases on, cutting over, why you cut over, the gains you've seen, operational things that you might see now. Is there anything else in terms of moving parts, in terms of how many services or components or things you might have expected to have had versus what you have with TinyBird that might be of interest?
I want to say that one thing that is like sort of popping up now as we kind of grow the product surface area of our product a bit more is it's also easy to have every incremental service that we may spin up also dump their data to TinyBird without actually doing any of this like infrastructure plumbing that we've been talking about. So the case in point is like we're working on a new service for effectively a second, like you want to call it a feature or like almost like a second product, which also just dumps all of its like metrics into TinyBird. And we again had to set up no infra to do it. It's very similar to how we're already doing it. We just like do a bit of micro batching and just dump all of this data using the ingestion endpoint. I imagine for like the alternate universe where we had not gone this route, we would have had to set up like yet another like Kafka topic that we would have to maintain, that would have its own sort of load characteristics over time that we just like don't know in advance. So it's great to just like not think about it. And I think I said this in my initial call with Cameron. Like as an infra company, we have enough infra problems on our hands, and the more we can minimize that, the better.
Awesome. It's interesting because, I haven't heard as many customers talk about, it's so much easier to add more ingest. And, there are less pieces that we needed to build to just do ingest. We often hear on the other side of it, and it'd be interesting to see, your take of it. How often do you find yourself using just TinyBird's API endpoints directly and just, you need a new API, just build a new endpoint versus starting to build a whole new microservice, a whole new REST API to serve up data? How's that working out for you? Is that, is that playing out the way I would think it would play?
Yeah, I think so. For the most part, I think the only issue temporarily, at least, was that TinyBird, I think you guys recently launched JWT token support. So we no longer have to have our front end kind of hop through like a backend service to get data from TinyBird. It can just kind of hit TinyBird directly. And yeah, that's been nice as well. So I think to answer your question in short, it's almost every single time when we have like an analytics use case, we initially just like start with getting the data into TinyBird, building the service on top of it. And so far we haven't had a reason to like change that, or haven't had a reason to revisit these things after the MVP of this feature is out.
Awesome.
It's like one part of the surface area that has not expanded up for us in a while. I can't say that's true about like the rest of our stuff, because the minute you start like building features and adding customers, like the surface area of your product just explodes without you even realizing it. But it's one of those like nice corners of the product which we haven't had to really think about in a while. So we also hope it continues to be this way. But yeah, we don't have to like design anything new, and we just want to get data into TinyBird at the moment.
Cool. Not asking you to divulge any numbers that aren't shared publicly, but when you're hitting TinyBird APIs, what kind of volume are you thinking? What kind of QPS do you have right now in terms of the amount of users and UIs and different systems that are querying TinyBird in real time?
I think we'd have to double check. It's not something we like actively track, but to give you a sense for what our dashboard, our UI does, currently it has to, I think, just to hydrate all of the data on our dashboard, it's making close to 100 queries. And I also don't think we like fully track the peak we've had in terms of like concurrent users using our dashboard, but it's been like close to a dozen at points. So at peak, it can handle, or we can kind of throw a lot of volume at Tinybird. And again, like we just have not had to worry about that. Whereas you can imagine how even handling like 5 users refreshing their browser at roughly the same time would not have worked with our old Postgres based setup with each of these queries hoarding up a Postgres connection slot for like a dozen seconds. That would cause a very noticeable blip in the service.
Awesome. So on that note, I think I want to get to something that JP was saying before, which is, are there any particular features that really stand out to you on Tinybird? Things that make your life easier, make it delightful, make it easier for you to develop. Like, what are the key pieces that you folks, as you've been playing with Tinybird and developing on it, that really stand out to you as something that, hey, everybody else needs to learn about this. People need to know about this, and they need to get in on this too.
Yeah, I can pitch in on that. I'd really love the pipes feature. Like oftentimes, for our customer debugging charts, we need data, and pipes is the easiest way to like create that data and pipe it to like retool. And I can do it in 5 minutes, and I don't have to worry about it forever.
Awesome. So, for those, for the folks who don't know Tinybird, what exactly is a pipe? At least in your words, right? From a user perspective, how would you describe a pipe? Like, what is it? What do you do with it?
Like the way we use it is it's a query that refreshes over time when we need it to refresh, and I can basically write SQL, create an API for it, and I can click a button in my dashboard and it gets refreshed. That's how I would describe it. I'm actually not even sure what the actual pipe definition from Tinybird is, but that's my use case.
Awesome. How about you, Maru? Is there anything that really stands out to you as like one of the favorite things you like doing on Tinybird?
Yeah, so for a large part of like this analytics feature work, I was actually not involved in Tinybird. My like first interaction with Tinybird was actually when the machines which I managed, like the 100 plus machines, started showing like degraded performance, and Ayush was like, why don't you pipe the benchmarks into Tinybird? And that's when I sort of logged in for the first time. So my favorite feature is just the fact that I can chart time series data in an easy way for some of these disk benchmarks, which we run on like a nightly basis. If there's any blip, then that's the source of truth for which box is doing badly, which disk that needs to be changed out. So yeah, it's surprisingly hard to find a service that just works when you want it to work. And in that moment, when you have like 10 failing disks out of 100, you just want to see a chart. And it took me 5 minutes to like just get those key value pairs charted and see where the issue was. So I expect myself to get my hands wet with more features of Tinybird, but that's been my favorite use case so far.
Awesome. And then Ayush, anyone that stands out to you?
We recently built one of our stats like tables in the UI based off of a materialized view in Tinybird, which was, again, like I wanted to transform like an existing data source into effectively like a nicer roll-up query, which was cheaper to run from the UI. And yeah, the fact that kind of the materialized views sort of update dynamically under the hood. I think as you alluded to earlier, Tinybird kind of takes care of ensuring that the views are updated as the underlying data source changes at a frequency that doesn't knock the ClickHouse instance over. Is just one extra problem that we have not had to think about. So now that we like now that we have most of our like source of truth data just being piped into Tinybird at a regular cadence, because of the fact that we can just define these arbitrary materialized views that update incrementally, we can effectively like reshape that data into any form that we want and power any kind of analytics that we want without having to do any data massaging or data processing on our own infra. And that's been nice. With a lot of serverless services, I find it hard to figure out how much am I going to get charged for like every additional use case that I'm adding. And so far, I think even that's been quite easy with Tinybird. It's very easy to figure out this is the volume of data that you're processing today. This is how much you're getting charged for it. And it's very easy to kind of add a new use case, observe it for a day, and be like, okay, so if I add this new use case, I'm going to pay X amount of extra dollars because of this like extra processing that I'm doing. So I think that kind of lineage and just the explainability of my usage has been kind of nice as well.
Cool. I mean, that's nice to hear. And I think, it's interesting. You mentioned materialized views because you had said originally you tried to do materialized views, but that wasn't going to work. But there's something about Tinybird and ClickHouse materialized views that's actually different, which is interesting. I'm not going to get into it here, but actually I think maybe the team in the background could put a link. We actually have an awesome webinar talking about materialized views and how they're different in ClickHouse and what are the awesome things you can do with them. I think Ayush, you might like that one too. We're going to go into a bunch of different use cases and examples of different materialized views and how you might use them in different use cases. So you might get a lot out of that. So, we'll probably get that link out very soon. So on that note, we're almost at time. We've got a few minutes left. I think the last question I have for you folks is, for anyone in your position, whether it was, right where you were reaching that pain point and you decided, no, let's not even do this. Let's go down Tinybird route. What would you suggest to someone who's thinking about looking at Tinybird versus looking at other tools? What would be your advice to them?
I think the first thing that comes to mind is just give it a shot because the self-serve is so easy to just like whip up and try out, and only consider going down the route of like managing your own ClickHouse instance or even using the cloud-hosted ClickHouse instance if you for some reason that Tinybird would not work for your use case. Yeah, I think that's how I would like say it. I think it's almost a no-brainer to at least like evaluate something like Tinybird just because of how much more quickly you can just like see some value.
Yeah, I think just adding to that, like if you're at the same intersection of like you need to ship features fast and you want to think about one less thing, because there's a lot of capable folks out there, and I would put maybe us in the same bucket where we can self-host if we really want to self-host, because our whole business outside of analytics is self-hosting stuff. This is one of those things where like it's better if you focus on providing actionable data to your users, making it look good and like figuring out the ergonomics of your dashboard, rather than and getting that out as quickly as possible, rather than spending several weeks trying to figure out how to get the data looking good first before you can even like think about that next step. So this is not to say that like there aren't other options out there, but I think if you're at this intersection of you need something which works really well and you need something which like you can forget about amongst 1,000 other things which you have to deal with when you're starting up a company, then Tinybird is definitely like a no-brainer.
Yeah. And just kind of going back to like where we were, and actually our team size has still been the same like when we were evaluating Tinybird and even now. But this is not our core business. And if it's not your core business, in my opinion, you should really not try to like self-host it. You should probably look for a managed offering. And if you're looking for a managed offering, you should probably look for something that does what you want and also has a lot of other cool stuff, which could be valuable down the line, like Tinybird.
Very cool. Well, thank you very much for that, gents. This has been an awesome conversation. I hope that everyone listening and everyone watching gets a whole lot out of this. It's an amazing journey hearing, and it's a journey that so many startups go through, right? I've got Postgres, it's growing. Let me just stick to one database. I don't want to use more than one database. And then you start realizing that's not going to work for analytics queries because they're so different. They're so multidimensional. And they're going to start taxing your database. And I think, I love how JP was saying, and Maru was saying, I don't want to bring down my entire use case and my entire platform because I'm trying to serve this particular use case. So awesome hearing your journey. So great and actually validating, to see what you guys are doing on TinyBird. I look forward to you guys bringing all that data, that 100x, 1000x data, and working with you on that journey. There's a link here on the bottom, tbird.co/try. Exactly as Ayush was saying, just join, try it out. It's really easy for you to just set up your use case, see the data, and turn it on, see it solve your use case. Also, another link here for the TinyBird community. We have a very, very active Slack community. You can join there, find out more, ask a bunch of questions, meet other people who are solving problems like you. And if you're struggling with anything while you're trying to test out TinyBird, you'll find an awesome community there that will answer it for you. But also, we're on there. Our dev advocates are on there. Our sales engineers are on there. Our customer success team is on there. So you'll see a lot of very, very talented, very knowledgeable people unblock you and help you on your journey of learning TinyBird. With that, I don't want to, walk away without giving you guys an opportunity to talk about, Blacksmith some more. Can we repost the link to Blacksmith on here so people can go check it out? Save money while running your GitHub actions, right? And, run them twice as fast at half the cost. Remember the tagline, very easy. And then, is there anything else you guys would like to announce? Do you have anything coming up? Any kind of events, webinars, conversations, or things that people should know about?
We don't have any webinars of sort coming up, but we do have an additional offering coming up next month. Just like how we make GitHub Actions run a lot faster, we're also going to help folks run their Docker builds a lot faster. So stay tuned. In a month, you'll be able to do that with Blacksmith.
And
very cool.
Newer analytics come with everything which we ship. So, another opportunity for you to check out how cool TinyBird is.
Powered by TinyBird.
Awesome. Very good. Will you put that on the website? That'd be awesome. We'll talk about that separately. Amazing. So thank you. There's a link right here about those materialized views as I talked about. Just, folks, if you can bookmark docs/live, we'll learn about all the sessions. We're going to be talking about materialized views on the 24th. Next week, we'll be talking about Mongo CDC into TinyBird and building your use cases. Thank you again. This has been an awesome conversation. I hope for all those folks that were listening and watching that you learned quite a bit about how you think about your journey, growing Postgres, migrating off of Postgres for your analytics use cases, and actually how the two can work together, and how offloading those real-time analytics use cases TinyBird can allow Postgres to do what it does best, and you get the best of both worlds. So thank you again, everybody, and hope you guys have a wonderful afternoon.
Likewise.
Cheers.